Said it's been a long time.
Yeah.
It's been a long time.
Yeah. Actually, I think we are conducted the session in
April.
August. I think in August or
April.
April. Okay. Yeah.
I mean, we talked about a section on net, CSI and net. I mean, in and around say June, if it was possible. But then I mean, I had
some personal reasons, inconveniences, and all that.
So then I couldn't do it. Then the next net also went.
Yeah.
And that was the reason I was so much eager to do it at any cost, because I mean after a few hours I will be flying to IIT Madras anyway.
Yeah, I know that. So that's why I ask you, if you are any kind of difficulty, then we can postpone.
No.
For me also, actually, in our group on this January, we didn't have any session. While checking with the resource persons, many of them have many other commitments and their PhD work and all that because of.
Actually, the thing is that the December is people are on festive mode, because after the Christmas time, normally January and July. January and June mid. Those are the timings when we really struggle a lot. That will be the time. My DAC committee meeting will be around, I think, that summer. But yeah, I have talked to few of our faculties. So I will try to arrange it by them.
Okay. Yeah.
We have right now we have around 20 faculties. From IITs, ISER and ISIs and all that. So some of them will be available, of course. At least one.
Then it will be a great help for us. Actually, nowadays I'm suffering very difficulty to get resource persons. Feeling very difficult. I have tried many persons, but many of them are very busy with their research. Some of them are writing thesis and all that. Yeah.
And you know what, sir? I just didn't want to have a one-off session, because it's, suppose 10 problems are there. Students are smart enough. ChatGPT is there. They can just type the problems and they will get the solutions anyway. So I always look for even when previously I took classes, I think it was a 3-lecture course or something like that, or a 4-lecture course, so that I can tell them a story. That is very important.
Yeah.
Yeah, you will get the video on YouTube. Don't worry. On our channel, on search channel, you will get it, Sandeep.
Yeah. So let me introduce you so that you can start. I may leave in between. You can continue with the class, because I have some work in. I have to visit bank and all that.
No, sir. Since you have told me, we have 1,000 reasons to postpone the class. Only one to take it. So
Yeah.
So from now on, I will try to arrange some of the faculties so that we can do it on a regular interval, actually.
Yeah, then it will be very good, very helpful.
Twice every month or something like that.
Yeah.
Because since I have so many faculties, so many options, we can do it.
So your help in that respect will be a great thing for our group. So let me introduce you.
Sandeep, don't worry. We will send you everything. Don't worry. It's our responsibility to send you the link. Don't worry.
Yeah, if any of you would like to join Math Aspirants, you can just WhatsApp to the number that I am typing now, so that you can join our WhatsApp group. In that, all the materials and other things are shared, and also resource persons like Abhirup are there in that group, so that you can ask doubts also there. So yeah, let me introduce our resource person so that we can start today's session without further delay. Dear friends, hearty welcome to the online problem solving session organized by Math Aspirants groups. As all of you may know, Math Aspirant is a community of research scholars, math students, faculty members across India, started by myself in 2017. And we used to arrange several online programs to help the students who pursue higher mathematics. So today we're blessed to have a session focusing on IIT JAM examination. All of you may know that IIT JAM examination is scheduled on February 15th. So only around 30 days left out for the examination. So we will, our resource person, Mr. Abhirup Das, a research scholar from
TCG Crest, Kolkata.
TCS Crest, Kolkata.
TCG Crest, Kolkata.
TCG Crest, Kolkata. Agreed to handle 3 or 4 sessions on the topic functions of 2 or 3 variables in the JAM syllabus. So today we have the first part of that session. So today he will discuss topics related with continuity in this session. So I request all the participants to actively involve in the session so that it will become more fruitful. It will be more helpful in your exams. So yeah, I would like to welcome everyone to this program, and I would like to thank Mr. Abhirup for the support he is rendering to our group Math Aspirants. The many sessions that has taken by him are available in our YouTube channel. That link of that YouTube channel, I will share it in the chat box. You can go through that. There are more than 200 video sessions done by research scholars and postdoc fellows and faculty members from all over India through our group are available. The recordings are available in that channel. So that will be a great resource for your preparations. So make use of it. And I take this opportunity to wish all success in the coming examination. And also, once again, I express my gratitude to Mr. Abhirup for joining with Math Aspirants. I welcome everyone to today's session. Welcome, Abhirup.
Yeah, of course. I mean, I will take a moment to see. I mean, TCG Crest is a relatively new institute, so some of you may not be aware of with it. This is actually, you can type in, if you type the name, you will see they are making quantum computers, I mean, along with IBM. Though I work in pure mathematics, but TCG Crest is an institute. It was founded by some of the retired professor of Indian Statistical Institute, IISc Bangalore, CMI, I mean Rajiv Karandikar, the ex-director of CMI, ex-director of ISI Vimal Roy, ex-dean of ISI SMU, StatMath unit Gautam Mukherjee. I mean, structurally they are trying to make something like CMI. I mean, the way CMI was created, it was established by the retired profs of TIFR, like Shishadri and all of them. So you can, it's a relatively new institute actually. It's near to where I live. That's why I didn't take the opportunities like IIT Roorkee or IIT Gandhinagar or some things. I mean, some of them I had. You can check in the departments. You can check the departments of the of this institute. Should you need it, I will just send the link in the group. So yeah, sir has thanked me a lot, but I mean, it's a great opportunity for me as well to sit in front of you, and I'm sure in time all of you will gather more knowledge in mathematics than what I have gathered at my age. It's just a process. Be there and you will do well, I believe. So we'll start with the definition of continuity in several variables, which I believe you already know. I will still, I mean, for the sake of completeness of this course, I will just state it, and then I will go through problems of JAM. Yeah, I think that will be good. Yeah, I think that will be good. Yeah, let's start. By the way, there will be 4 lectures at least. That's why I was so much eager to take it today, because I mean I won't be available for the next 7 days. I will be off to IIT Madras. So join the classes. Okay, there. I mean we have agreed to have 4. I mean I'm telling you at least 4. If I can, I will take at least one more. Let me see, because I mean JAM is really around the corner. Okay, so let's start. I'm just switching off my video and sharing my screen. Sir, there is a problem. They are showing that I'm not allowed to share the screen at this moment. Is there a problem?
सर आपका मार्क आ रहा है बस।
Sorry?
आपका मार्क आ रहा है लेट्स स्टडी विद ऐसा कुछ लिखा हुआ और कुछ नहीं आ रहा स्क्रीन पे।
No, 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 no. I mean, they are showing me that I can't share the screen. Why? I think
हाँ
there should be some. Wait a moment. Let me call sir. I think there is something in the settings of the meeting. Just give me one moment. There is something I think in the setting of the meeting. Sir, I can't. Just wait for 1 minute. I mean, I have informed sir. He's probably adjust the settings accordingly.
One minute, Abhirup. Sorry for that. 1 minute. Let's. Now you can do, Abhirup.
Yes, of course. Thank you, sir.
Okay, right.
So the whole note will be just created here. Okay, you will get the full notes. I mean, not just class wise, the combined one. Am I audible to you?
yes sir.
Okay, and my screen is visible, right?
Yes
Yes,
sir.
it is.
Okay. So let's start with a general definition of continuity. So a function if from Rm to Rn is said to be continuous at a point A equals to say A1 to Am belongs to Rm if for every epsilon greater than 0 there exists delta greater than 0 such that for any x with we have fx minus fa. You know the meaning of the Euclidean norm, right? The distance between fx and fa. Okay. So this is that is if norm x minus a is less than delta, we have norm fx minus fa less than epsilon. You replace this sign by this sign and you just get the continuity over R, right? So this is the definition. I think all of you know it already. So there is a thing. I mean, I think all of you have noticed. Okay, let me just ask you a question. Can you say, I mean, what is a very fundamental difference between R and the other, I mean, other Rn for n greater than 1? Yes, they have higher dimension. Okay, fine, I understand. They are all vector spaces and all that. But can you tell me what is a very fundamental difference? So say if f is a function from R to R and f is a function from Rm to Rn, can you please tell me there is a very fundamental difference?
I think ordering.
I mean, can I know who is it? Because you are spot on. So I mean, may I know your name? Because I currently.
So I'm Supratim Santra.
Okay, okay. So you are just spot on. R is a field, is an ordered field.
Yes,
And these are not.
ordering is the in RM and RN or higher dimension there lack of ordering under if we not define their norm or something like this which have on a mapping on R which is a ordered field.
Yes. So as a consequence of that, we have intermediate value property in R, right?
Yes, yes.
That is a thing that is missing in the higher in the higher dimensions. So you don't, once you don't have intermediate value property, you don't have Rolle's theorem, you don't have Lagrange's mean value theorem. So I mean, in Supratik, what Supratik just said, I will just say it in a very layman's language. In R, there is only two directions, right and left. Right, Supratik? Increasing,
Yes, yes,
decreasing.
yes.
There are only two directions from a point. The problem with any other Rn is that you have uncountably many directions. I mean, why I tell you? Because whenever, I mean, you will see that in a moment. When we define the limit, you will see how this, how this makes a problem. So let's start with our first example. So see, when I have defined continuity, I mean, I am assuming that you know the definition of limit already, because see, I mean, if I have to build the theory from the scratch, then I won't have much time. So the first question, or maybe say example. If I believe all of you already know these problems or have seen the solutions, because I'm sure you're all very serious students anyway. So it's a scope to me to teach you. It's an opportunity for me more than an opportunity to you. So the question is if continuous Yeah, tell me. The standard
कंटिन्यूस
approach?
नहीं होगा सर ये
Yeah, it won't be. Why?
सर इसको हम y इजिकल टू एक्स के अलोंग करें या फिर y इजिकल टू एम एक्स के अलोंग करें
mx1. Okay. Let's compute the limit at 0, 0 along the line x2 equals to mx. This is the line x2 equals to mx1. So you're approaching 0 from that line. So what you get? So what will be your f of x1 comma x2? It nothing but f of x1 comma mx1, which is m x1 square by x1 square plus m square x1 square. See, I have a tendency to make silly mistakes, so please pay attention. I'm horrible at computation anyway, so please pay attention because there are high chances that I'm gonna make some sort of a silly mistake. X1 square, yeah, that's fine. One thing you see, we can cancel out x1 square because as you can see, I mean, x1 is not yet 0. We are approaching by this line. I have written it. Okay, since we are approaching by this line, x1 and x2 are not apparently 0. Okay, so limit x1 x2 tends to 0 or maybe I should write limit x1 tends to 0 f of x1 mx1, you see, depends on the depends on m. That is, the limit can't exist, right? Because if you change m, the limit will change. Now you see what I mean. Supratim just was just talking about that how the fact that R is not an ordered field makes the difference. You see, this can never be the case in I mean, in R you have only left and right, so only two directions: the left hand limit, the right hand limit. Okay, so at most you can have so what should I say? At most you can have two limits. But here you see the limit is approaching from every possible direction, which is uncountably many. Okay, let's move on to the next example. By the way, let me write this example and then I'll ask you something. Is f continuous? See, if you are asking something by typing typing in that inbox, I can't see it. I can only see what you can see. So I won't be able. I mean, when I'm sharing from Meet, I can't see what you are writing. So you'll have to speak out.
इस बार हो जाएगा सर ये कंटिन्यूस.
He is saying that it is continuous now. So we will prove it. But before that, okay, let's prove it. Then I will ask for it. But I mean, what is the intuition? Why should it be?
जैसे सर पिछला किया था वैसे ही सर इसको ऐसे करेंगे तो जैसे x इजिकल टू एम एक्स x1 लिखेंगे तो सर
no. I mean, what is your name, by the way? I mean, I can't recall.
संदीप सर.
Yeah, Sandeep, you see, the problem is that that is the way to prove something is not continuous. If it depends on m, you can say that it is not continuous. But if it doesn't depend on m, it might depend on something else. So I mean, you see, so suppose there are straight lines. So there might be a path something like that, na? Along which, if you approach, it may not be continuous. When you are writing, just a moment. When you are writing mx1, you are choosing a path which is a straight line. But you can, I mean, you can reach zero. You can approach zero via every sort of a path. I mean, yeah. I mean, someone was, I think, trying to say something. Who was it? Yeah, can you please say? I mean, someone tried to say something. I was quite sure.
Yes, yes. দুখানা পাথ দিয়ে যাওয়ার পর যদি অ্যানসার ডিফারেন্ট আসে তাহলে সেক্ষেত্রেও মানে লিমিট এক্সিস্ট করবে না.
Yeah, I mean, I don't recognize the voice. May I know who is it?
Path test only for discard continuity.
Yeah, but that will only discard continuity. Is it Devayon? The voice?
Use polar test for continuous, proving continuous.
You see, I mean, Devayon, the problem is that I mean, you can prove something is discontinuous by that if it depends on m. So I mean, there can be a path like this, na, mx1 square. I mean, like a parabola type thing. So how will you say? কি করে বলবি যে ওটা দিয়ে কন্টিনিউয়াস হবে না? It's not possible to choose every path possible, na. So we will check it by, I mean, whenever you are stuck like that, there is a theorem. We will move on to that in a little bit. Okay, but it is easy to compute direct from the definitions actually.
Yes, sir, because it is continuous, because x1 is a positive quantity, x1 square positive quantity, which is less than x1 square plus x2 square, as well as x2 is also root over of x1 square plus root over of x2 square. And if we multiply them as they are not equal to 0, this quantity should less than root over x1 square plus x2 square. And this should be make small closer to 0, as we want. That is why it is approaching the 0 whatever path we choose, and that is it is continuous.
Yes, you're quite right, to be honest. Can you see this? Just see this. See, I mean, analysis is a game of inequalities and counterexamples. So is this thing clear to you guys? I mean, once we write this, let me change the color first. This is less than equal to 1, right? This one is obvious. Sorry, isn't it? The denominator is bigger than the numerator and both of them are positive. So of course this is less than equal to 1, no? So right from that we can write this. We have just multiplied both the sides by mod x2, nothing else. Okay. You see, this thing is again less than, correct?
Yes, yes,
Okay. So let epsilon is greater than 0. You will have to choose delta, right? But
yes.
you
For a
see,
given epsilon,
yeah,
we have to choose it.
you have to choose the delta. So that is you have to back calculate. So we have just shown that fx1 comma fx2 minus f of 0 0 comma 0 0 is less than mod of x1 square plus x2 square, right? Which, so you can choose delta equals to epsilon, na?
Yes,
Okay. Now what I was talking about before giving the problem is how we'll get the intuition. Look at this problem. Okay.
yes, yes. Intuition is great important because we don't know in
Yeah.
prior knowledge whether it is
I
continuous
mean,
or
what
not.
will you try? What will be your attempt? I mean,
Yes,
should
yes.
you try to prove it or disprove it? So you look at this f x1 x2. Look at this function from the previous example and from the current example. What do you notice? There is a very apparent. I mean, there is a very apparent distinction. What is it?
তো
Is
উপরের ডিগ্রি আর নিচের ডিগ্রি সমান,
Very good.
আর ওখানে উপরের ডিগ্রি বড় নিচের ডিগ্রি ছোট।
Hmm. Yeah, someone was trying to say something. I mean, apart from Devayan, who was it? I
হ্যাঁ,
couldn't remember.
আমি বলছি।
Hmm. Yeah, so basically what happens is that what he is referring to is that there you see the degree of the denominator. I say deg, dim, denom and deg num. Okay, so you say deg num is less than equals to deg denom, right? So the degree of the numerator is less. I mean, we are talking about polynomials. So what happens is that if you approach 0 0, this quantity will have a greater speed than the numerator. So the denominator approaches 0 0 with a greater speed than the numerator. So the whole fraction will have a tendency to reach towards infinity, right? But if you look at it, you see, so for the time being, don't think that there is x2, right? If there is not x2, this function is not continuous, right? This function is not continuous, but this is. Why? Because now the degree of the numerator is greater. Now it approaches 0 faster than the denominator. Okay. Is that
one
clear?
question. How
Just
to?
a moment. Just a moment. Just a moment.
Okay,
Just
okay.
a moment. Is that clear? What I have just said, is that clear to you guys? If not, then ask it. I can repeat it.
আরেকবার রিপিট করবে দাদা?
What I want to say is that you look at this function. Okay, so let's call it a RAF. I mean, so RAF. So suppose you have been given if x1 x2 by g x1 x2. Okay. And you see deg f is less than equals to deg g. So you see, whenever we are reaching towards 0, because of a greater degree, just intuitively think, forget about all this. Just think about fx1 and gx. Okay, just think in one variable. And deg f is less than equal to deg g. Okay, so fx1 will be like some a1 x to the power some say m, and the below will be say b1 x to the power x1 to the power some n, some other quantities, m is less than equal to n, right? Now you see, you can clearly see that the denominator approaches 0 faster, right? So if the quantity at the bottom reaches 0 faster than the above, then it will become something like, I mean, by 0 type of fraction, na? So that will reach to infinity. But once you have m greater than equals to m, then this reaches faster. Now this will go to 0. So your first intuition should be the polynomial at the numerator is having a higher degree. Okay. Okay.
Okay.
Oh, so someone was asking a question. I just stopped him in between to complete what I said.
It is nothing but how to determine the degree. Degree means here the whole aggregate of the power of the each term. Okay. Okay.
Again, whose voice it is? I can't
Yeah,
recognize.
I'm Supratim.
Supratim. Yeah, I can recognize the accent actually. That you are Bengali.
Yeah.
You are Bengali. I can recognize the accent, but I can't recognize the voice.
Okay.
And I will say we have used this kind of logic in single variable calculus as well, isn't it? You see, whenever we were told like what will be this limit, or say what will be this limit,
Yeah.
we were always seeing that this reaches to infinity, so let extends to infinity, and this reaches to infinity as well, but this reaches to infinity faster. So we have actually used this logic. So let's do one more example. So again, if it's a function from R to R, you will see I am taking R in the codomain always. There is a reason for that, and of course we'll talk about it. So what about it? Is it continuous?
No, sir.
Is it continuous? Someone said no. Tell me why. Look at the solution of the first one. What was your goal? Your goal was to keep m and cancel every other term, right? That we will cancel x1, x2, and we will keep the m only, right? So that we can then say that the limit depends on m. That was the whole approach. So tell me a suitable.
Yes.
So first of all, again the intuition. There is a possibility that that the limit won't exist, right? Because the degrees are equal.
Because it may goes to 0 or other something value, or depending on the nature of the path, because both degree are same.
So give me a path. Give me a path at least.
Yeah, y
the path is right in front of you. The path is right in front of you. Yeah, go ahead.
Y is equal to mx something.
That won't work this time. If you take y equals to mx, that won't work. You are trying to say x2 equals to mx1, right? So
Yes.
Put it there. So what is your fx1 comma mx1? What is that? mx1 square by x1 square plus mx2, isn't it?
Mx square. Right? Not square.
MX.
Okay. Yeah.
So you cannot cancel all the x1s, right? I mean, you can only cancel one. Yeah, go ahead. Only that. So this reaches to 0, but I mean, so this path won't work. Yeah, yeah, হ্যাঁ কে বলছিলি বল।
হ্যাঁ, যদি আমি x2 ইকুয়াল টু x1 স্কোয়ার বরাবর যাই, মানে এই পাথ বরাবর যাই, যদি x1 স্কোয়ার ইকুয়াল টু x2, এটা তো 0 0 দিয়েও যাচ্ছে।
Yeah, but that doesn't involve m. At the end, you will have to conclude that because of m, the limit doesn't exist. So you
আচ্ছা,
should be saying that can we take this?
হ্যাঁ হ্যাঁ,
So let's see if fx1 comma minus mx1 square. Please tell me, I mean, what should it be? So x1 x2, that is what? So putting x1 x2, we get what?
x1 cube minus m huh, 1 cube, and
So you see this doesn't work at all.
yes,
That is because we are not being able to cancel x1 square. That's the main thing. So you see, we can choose something. Okay, we can choose.
sir, if we choose the root, I think y is equal x2 is equal to root x1 or x1 is equal to root x2, something like that. That is why
Keep it there.
denominator getting root free and denominator.
So I am giving you a path. You see. So you see, Devayan, what he was telling is that can we choose this? Now, if we choose this, the problem is that you have 0 0. Now he is going along this path basically. So what we can do is that just add mx1 cube last. Now calculate it. What will be your fx1 x2 along this path? What will be? Tell me. So this is just x1 times minus x1 square plus mx1 cube, and below you have x1 square plus x1 square plus what? Minus x1 square plus mx1 cube, right?
Yes, and with cancelling
Cancelling out, you will be left with mx1 minus 1, I believe, and then it is right by m, right?
yes.
Hmm.
And it is depend on m because
Exactly.
x1 goes to 0.
If you take x1 going to 0 and limit x1 x2, I mean along this path, of course, I mean along this path, it is minus 1 by m. Now you might ask me a very obvious question. How do I recognize the path? I mean, how do I know a priori that which path is going to work? See,
Yes. So which
for the
type of
timing, this is just your intuition and scratch, because there is a way to do it. But I'm afraid you guys are not aware of it. Do you know implicit function theorem?
it is not included in our syllabus.
Jam syllabus. No, I know it. But so that is, so in implicit function theorem, what do we do? If you know it, what do we do? We basically express one variable with respect to the other, right? So that is the path.
Yes.
So that x2 is being written as a function of fx1. So that's how you actually come up with the exact path. But okay, I mean, by scratch you can do it also. I mean, by just trial and error, because now is not the time to learn implicit function theorem. That's why when we teach, sometimes if the students are interested enough, we prefer to teach a little bit extra, because the problems those are given, these are given by a very, I mean, those are stalwarts like IIT professors are there. So they are sort of using their knowledge to come up with a problem which you should attack without knowing these theorems as well. But the problem is that it's easier once you know the thing, I mean, know the theorem, because theorems are there to make your life easy. Theorems are there for a reason. And it's not a lot actually. Implicit function theorem, inverse function theorem, done. I'm not talking about integrations and forms and all that. Just a little bit. Because you see, I mean, if you want a good picture of a land, the only way to do is if you go above with a drone, and only then you can see the land properly. So I always prefer that you start preparing early and know at least a little bit more than than your exact syllabus. I'm not talking about jam, because you will crack it anyway and you will get a good double digit, single digit rank. So, but I mean, I'm doing this for your future preparation. Whenever you are preparing for something, keep this in mind, that start early so that you can be ahead. Is this? By the way, can I take a break for 2 minutes? I just let me drink some water, okay? Just give me 2 minutes. What do you think?
It is continuous, whether it is asking continuous in 0, 0, okay?
Mm-hmm.
Yes,
Because see, everywhere else it is continuous, na?
Yes,
that is direct.
I am thinking just by seeing those problem, because sine 1 by x does not exist. If we take x1 is equal to x2 is one of the path, and x1 is equal to 0 along x-axis, along y-axis, and along x is equal to y-axis. Those three paths shows the difference in approaching 0. That is why I think it is not continuous at 0.
Okay, Shubhratim, let me tell you something.
ये continuous है sir.
Yes, Sandeep, you are right. Shubhratim, look at this function. Is it continuous at 0, 0?
Yes, because it is sandwich limit. That is why those end are.
We will use that same thing. So the shenanigans that sine 1 by x is gonna make, we can eradicate it by that multiplier of x. Okay. So what Shondeep was saying is absolutely correct. So what will you do is that just again let's do some inequality. So 0 x1 sine 1 by x2 plus x2 right, Shubhratim? This
Yes,
inequality
yes,
it
and
stands.
this one is root over of x1 square plus x2 square. I think getting closer 0 to 0 as we
Yeah,
want.
yeah, this thing is less than equals to root over x1 square plus x2 square. So is this. Okay. So that is twice x1 square plus x2 square. Okay. So I mean as we are just talking. So if epsilon is greater than 0, we have shown that fx1 comma fx2 minus f of 0 0 is less than what? Twice x1 square plus x2 square. So this is less than, I mean, in a way, twice delta, right? Because we want x1 square plus x2 square to be less than equal to this, right? So you can choose just delta equals to epsilon, no? Epsilon by
Yes,
2, sorry.
epsilon. Yes, yes. But here constant is not matter of definition of something. If we
Yeah,
take
yeah, yeah.
delta is equal to epsilon, but it is a constant and epsilon or delta is uh, uh,
It
reducing
doesn't
to
matter.
yes, yes.
It
For
doesn't matter.
sake of showing the exact form of delta, and that is why we are multiplying or dividing by suitable number.
Hmm. This is one delta, not the only one. Okay, let's do another example. Do you guys use that r theta method?
Polar form, yes. Sometimes it is useful, but when it is useful, that is a question.
Hmm. The problem is that, okay, I won't be fine. I mean, whatever works for you, whatever has worked for you up until now, stick to it. That's all I can say. But we can have a discussion not about them, but say about, I mean, this sort of approaches. That approach is quite tricky. But if it works for you, then go ahead with it. I don't want to break your confidence. But I mean, that approach has a lot of problems. Just you said that when to use it and when not. That's problem one. And the problem two is when it is correctly applied. Because if you see, okay, you don't probably. I mean, the double and triple integral are in your syllabus, and you have done a lot of change in variable, right? Like, I mean, you are given that if is you are integrating like dx dy, then you have sort of done this like if uv, if du dv. You have done this, no? Change in variable.
Yes, yes,
And you have shown that the transformation taking x to u and y to v, the Jacobian should be non-zero, right?
yes,
Yeah. So the Jacobian should be non-zero because then the xy thing transform to u and v without losing any informations. But you see, when in one variable we used to do such things like, and we say put x equals to sine y or something like that, did we really check whether f prime x is non-zero or not? Should have checked it, right? Because f prime is x is a Jacobian in one point. But if you see those 11, 12 level problems, they are given in such a way such that f prime x is non-zero. You can go and check. You pick a Besende or any book like R.D. Sharma, whatever it is. You see those problems, they are having in that particular interval in A to B, f prime x indeed is non-zero. So the problem lies in, again, we haven't checked it. So how do we know that if there is not that particular interval has that criteria? So it may happen that f prime x is 0 somewhere, and then your integration will fail. So there are a lot of things in those methods, like how to use it, when to use it, and when it is being applied properly. So I prefer the inequality method, but again, I can't stress it long enough that whatever has worked for you up until now, stick to it. Don't change your approach 3 weeks prior to the exam. Oh, it's actually 4 weeks. Sorry. I don't want to reduce the time. Okay, what's your intuition? We have just talked about it. It won't be continuous, right? The denominator has clearly, higher degree. So let's just put x2 equals to, it's enough to put x2 equals to x1, So then if x1 equals to x1, what do you have? You have twice x1 square plus twice x1 cube, which is 1 by x1, right? The limit does not exist. No, I haven't written, limit at every step. Just racing past it. By the way, in future, we can do one thing. If you have a collection of problems, you can come up with it. You can upload it in the group, and then we can arrange a class to solve those problems. I don't know how much time I will have, but maybe I will try to arrange it by some faculty. You can do that as well, okay?
Okay, thank you, sir. It is helpful for the more we practice and the more we are expertise about this. Otherwise, it is difficult during exam to.
I will say discussion. Discussion. So you see, till now we have only worked with function from R2 to R. Can you tell me, is there a difference in Rm to Rn? Because you see, there will be vectors like, a point is like that, right? And it is being mapped into an n tuple. So that will look like fx1 to xm, right? f2x1 to xm, if in x1 to xm, right? Where each fi is a function from Rm to R, correct? So I'm checking component wise. Each component is a function of x1 to xm, right? From Rm to R. We will see that if is continuous, or maybe I should write like this. If is continuous, these are component functions of f, is continuous if and only if I from Rm to R is continuous for each I Makes sense, na?
Yes.
There was only one component from R to 2 if the codomain is R. So it is. So I think it is a really powerful, because then you are not having to deal with those. I mean, an mth norm here and nth norm there, like those weird sort of Euclidean inequalities, summation xi square minus ai, summation xi minus ai square root over and all that. It's enough to check component wise. It's a very powerful tool. Hmm. Tell me whether the limit exists. It's a good one. Hmm. Sample. Example 6, right? This is 6. A. F is again from R to R. F of x1, x2, x1, x2 minus 1, cos x1 square plus square. What about limit, continuity, and all that? What do you think?
Maybe we need polar coordinates over here. 1 minus cos will be 1 minus cos r square it will be. Then because it is 1 minus cos r square, it can be substituted as r raised to 4 by 2 by Taylor's expansion.
What are you saying? Just give me one moment. Let me write it down. So, Srushti, what are you saying?
Sir, polar coordinates.
No, I am not polar coordinate. So, don't tell sir polar coordinate. You are. I am Abhirup.
Okay, sir. I'm saying we can use polar coordinates here.
Okay. Yeah, tell me.
x1 will be r cos theta, x2 will be r sin theta, and 1 minus cos r square it will be inside because
Then inside it will be what? 1 minus cos r square, and outside it will be, so r square sin theta cos theta. Once we substitute it, 1 minus cos r square, then I'm horrible at computation, so check. This will be r cube, right? Below it will be r cube, na?
yes, sir.
No, r to the power 5. Extremely sorry, r to the power 5. Right?
Yes. At raised to the power 5.
So we have sin theta cos theta 1 minus cos r square r cube. Yeah. What should we do now?
Because cos u has Taylor's expansion of 1 minus u square by 2 and so on, we can take 1 minus cos r square as r square whole square by 2. R is
But
2.
the numerator are bounded and r cube r goes to 0. That is why it makes difficult for if it were r cube in the numerator, then it will work. I think.
Yeah, Sushti, go ahead. I mean, so whatever you are saying, and Supratim, just see. I mean, interact with each other. Don't just interact with me. Yeah. So just tell me, what is the problem?
No, sir, I was just suggesting that you can use that cos ka Taylor expansion there, and then the denominator is r raised by 5. So I was just trying to remove that r, but I guess he has a point.
So when I'm writing cross, this means the method has not worked for this particular problem. Okay. So you see what we can do. Yeah, that is the problem. And you see, Srushti and I mean Supratim both. When we are replacing x1, x2 by r comma theta, shouldn't we have a Jacobian factor?
Yes, yes.
Now that is the problem with this r theta method.
Yes, because
we will do it directly. Okay, we'll do it directly, and it will be easier. Don't worry. Plain trigonometry and high school level, I guess.
you are going to convert this 1 minus cos something.
So what is 1 minus this thing?
It is sine square. Sorry, it is 2 cos square x square plus y square by 2.
I'm writing it as sine square x square plus y square by 2. I'm using cos x minus sine x is, I mean, that thing.
Yes, yes.
Cos square x minus sine square x, that thing.
And 1, 2, extra 2.
Yeah, I mean, just added it to here.
Yeah, and use this fact, it is bounded sine square.
Yes, of course, we will do. So what we can do is that we have taken the 2 outside, write it here, write like this, sine x square plus y square by 2 toward x square plus y square. Oh, there is no need of the root actually. X square plus y square. Just see whether I'm making a silly mistake or not. Right? Is that correct, whatever I have written?
Yes, yes.
It's correct, no?
Yes, correct.
Okay. Now see this. This quantity, I am writing it A, okay? So I will just erase it and take it here, okay?
Yes, yes.
I'm naming this quantity as A, it's V. Tell me, A is less than equal to 1, right? Because it is like of the form sin x by x or something like that. Isn't it? Oh, I told you. I'm just horrible at computations. So once I have done a 2 here, something will be multiplied there. So does it work? This 2 is here.
I think extra half should be added, should be multiplied.
Here, na?
Yeah, because in numerator.
That's yeah, that's it, right? Yeah, that's it. Right, Shubhradin?
Yes.
It won't change, I mean, to the conclusion, but I mean, still. So you see, whatever you have inside, that is sine theta by theta whole square, right? That is bounded by 1. So A is bounded by 1, isn't it?
Yes.
So what about B? You see, when you are writing xy by root over x square plus y square.
And x is itself less than root over of x square plus y square. And y also that manner, and this would get it whole quantity xy by root over of under this less than root over of x square plus y square.
So he is saying that x is less than equals to x square plus y square. So is y. So he is saying that the multiplication is of course less than this. Okay. So that is, it is less than x square plus y square root over x square plus y square. That is root over x square plus y square, right?
Yes, and it is again
limit x tends to y tends to 0, 0. I am writing AB. So half is there. Let's put it there. AB in our notation. This thing mod is less than equals to root over x square plus y square, right? Right, which is 0.
Yes.
So indeed it is continuous, right?
Yes.
You see, Shushti, so your first intuition was not correct.
Okay, sir.
See, we will conclude today's class here, and in the next class we will start with these problems, okay? Because that is a whole new concept we are going to. So I will just write the problems here so that it is easier for us to get a track. So problems, example 6 I think have done. So example 7 and example 8. Srushti, can you see what is tan inverse x and y? This is theta, na? Basically, if y is cos sine theta, x is cos theta, then tan inverse that is basically theta, na? Hello.
I was not listening.
That is basically theta, na?
Yes, sir.
So at least we should be looking at if theta is a continuous function in x and y, right? That's a very basic requirement, na? We are replacing x and y by some functions. Okay. X and y is continuous everywhere, right? From R to R. So at least we should be expecting if theta is continuous or not. Because R is continuous. R is nothing but root over x square plus y square, which is continuous everywhere. But theta is tan inverse y by x. So we will start with these problems, okay?
Okay, sir.
Okay. So
हेलो सर.
या प्लीज.
जो शुरुआत में आपने बताया था ना कि f from r to r और f from r to m to r to the power n, ये डिफरेंस क्या था सर?
वो difference क्या था?
हाँ सर।
Supratim mentioned that R is an ordered field.
जी सर।
And the rest are not. But why that information is important? Because you see in R you have only two directions, right? Left and right. That is one increasing, one decreasing.
जी
And
सर।
because of that you have intermediate value property, right?
Okay sir।
Because if I take A and if I take B, then I mean my function, then every value inside A and B will be obtained by F as well, right? That is intermediate value property. But the problem is that if you take away the field structure R2 and Rn, you don't have the intermediate value property. Because I mean you to reach A and to reach B, you have thousands of paths, na? Uncountably many paths. Once you take away that intermediate value property, you no longer have the likes of LMVT, Lagrange's mean value theorem, Rolle's theorem, all that.
Okay sir।
Since you have asked this, let me just write this as a problem. I mean, just so say example 9, and this is not actually example 9, this is an outside example. Okay, so suppose if x to y, I'm writing it as a function, it is from s1 to r, okay, to r. The function is defined on s1, okay, from the circle to r. Any function. The domain is s1, the codomain is r, okay. S1 is inside R2, so of course we can define something there, the closed subset of R2. Now I'm writing this. Can there exist a function f from S1 to R which is injective or surjective? Think about this. Okay. So before we conclude today's class, just stay with me for a while. I'm sharing of the screen and let me just, okay, first of all let me just send it because I can forget it again. So the audience I believe is quite heterogeneous here. You have come from different backgrounds, from different states. So you see, I mean, as sir just introduced me at the beginning of the class with another institute named Let's Study School of Mathematics. Okay, so we are in a way a bit different from the other academies. I mean, I know every academy claims that, but we are in a way truly different. Why? Because Srushti is there, Snehashikta is there. I mean, few of our students are there. Oishik is there. I think, Devan, I can't see him. He was there as well. So you will know, we always prefer textbooks. Yes, we offer crash courses because of the time constraint, but we will always prefer textbooks and to start early. Then for the last 2 months, we will give you everything possible. Mock tests and mock test, MCQ sessions, problem sessions like the one we just had. We will offer you everything. But till that point, we will prefer textbooks because you see, the problems are taken from the textbooks, then they are converted into MCQs, then they are given to you. So it's better to learn from the source than to learn from the result. So yes, I mean there are our channels are there, so you can of course go out and check that what I am saying. We will Rudin is a tough book, Hoffman is a tough book, Artin is a tough book. Yes, they are tough books. That is absolutely true. That's why you need a teacher. Everything is tough. Mathematics in general is tough, brother. So that's why you need a guide, you need a tutor. Sir was there with us when when I first introduced myself back in March. That's why you need a tutor who can sort of what should I say, who can dilute the content, those stories, a tigress, how she raises her cubs. So वो पहले ना वो मीट को लेती है, ठीक है. First of all she takes the meat, then she chews it for a while. Once it is softened, she gives it to her cubs. But in due time, her cubs learn to not only chew the meat, learn to prey on their own. So that I think is it is needed. The MCQ solving sessions, problem sessions, these are absolutely necessary. But don't just restrict yourself to that. That will be my request, because soon you are going to go to IITs, IISERs, and the previous institutes. The paper setters of JAM will be teaching you, will be giving you assignments. You better be ready for that. Okay. Thank you for being with me. Thank you for tolerating me for this long. We will see you, and I will once I move to IIT, I can actually see my schedule, and then I will of course then I will mention the next timing. Just tell me, are you guys comfortable with the late night slot, like from 10:30 p.m. to 12 a.m.? Is that okay with you guys? I'm just asking. I'm not fixing anything. I'm just taking your options. Is that slot okay with you? That 10:30 p.m. to 12 a.m.
सर दिन में रहेगा तो ठीक रहेगा.
Actually, see, what happens is that we are all active researchers in my academy. Okay, so since we are active researchers, we have our research and we have our institutes. Soon you will have it as well. So we are available after night. I mean, after say the evening onwards, and then their dinner times vary from IITs to IITs. The dinner times vary. Okay, I will try to keep it at least in the evening if possible. Okay.
Okay,
Sir, I think sir will create a poll and vote.
Yeah, creating a poll is good. I think Supratim's idea, because Sandeep, I mean, in the evening.
Otherwise, the session is recorded, and other student also access later as his or her convenience.
Yeah, that is true. But I mean, a live session, it can never replace a recording. I mean, a recording session can never replace a live.
Yes, sir.
Yes. First of all, you guys have enough. You guys have enough patience. Okay, my kudos to you guys that you can watch a recorded lecture. I can never watch it. I can never watch a recording for 15 minutes. Okay, so I mean, but of course, I mean, some of my students have that ability. Okay, so because in the daytime now we have the seminar, and also I mean in weekdays, we will have to go to the institutes, because if you see our our faculty list as well, I mean all of them are, I mean, researching as JRF or SRF somewhere. Okay, thank you guys. We'll see you.
Thank you, sir.